Well, if we look at any object, especially one we know something about from past experience, and I'm going to take this mug or cup here, and I'm going to pick it up. And I predict, first of all, that I'll be able to pick it up. And when I move it like that, it'll change its shapes to you. In other words, this will become more like a circle. That will be an ellipse when it's tilted. It goes through transformations. But my brain tells me that this is not actually changing its shape, that it's remaining truly circular, although it's elliptical there in your or my eye. That's the first point. So the hypothesis is from changing images in the eye to an object which is not changing. It may be tilting, it may be getting nearer or further away and so on, but its actual shape is remaining fixed, although it's not fixed in the eye. That's the first point. So the hypothesis takes you from the changing retinal image to an object which goes on having a circular top. It's parallel lines here, and it's got a pattern on it which in a way is painted on it. It's separate, in a way different from the cup itself. It's seen as a picture, and that's an interesting distinction. What is an object, what is a picture? All that comes out in this thing. Now, again, when it's moving, you find that the different parts of it all move together. And this is actually very surprising because the eye signals these different characteristics, shape, colour, movement, in parallel different channels. And yet to the brain, it's all moving together, though the signals from the bright bits, that is the white bits, are going to arrive at the brain sooner than from the dark bits, such as these parts here in the picture on the cup. Although these differences in time should mean that the thing dislocates, parts moving faster than others, it all looks like one object moving. So they're locked together. There are locking processes, which we call them border locking, which hold different parts of the image together for the object as it moves. So there's an amazing business here of signalling parts of an object, seeing it as one object, combining the parts together so they don't dislocate, although the signals arrive at different times when it's moving, seeing a circle actually becoming an ellipse in the retina, but we see it as a changing positions of an object. So there are all sorts of transformations here, and a lot of it depending on knowledge that a mug is a thing you can pick up. If you take computers as a way of thinking about the brain, you've got parallel processing, where you've got the operations going on at the same time which converge, or you do it step by step by step serially. Now, the thing about parallel processing is that it's much, much faster, and everything suggests that the brain is a parallel processor. There are different regions that are handling different parts of the problem at the same time, then it comes together and you get the answer. Everything suggests that. And the anatomy of the brain suggests it, and a lot of phenomena of perception suggest it, and also the analogy with any sort of information processor, such as a computer, suggests it. So I think there's no doubt that it's parallel processing. You've got dedicated regions of brain carrying out special processes, and it ends up somehow with a final answer. We don't know quite how that happens, actually.